We are now on question 3 of practice 4. Study the relationship between blood pressure and cholesterol at the beginning of the study. What do you conclude? In this question, we have 2 quantitative variables, blood pressure and cholesterol. When we have quantitative variables, we need to look at the distribution and decide if the distribution is normal or non-normal. So go back up to the table. We are here looking at correlation. We need to check for normality. If both variables are normally distributed, we will use the Pearson correlation. And if one or both of the variables are non-normally distributed, we will use the Spearman correlation. So in SPSS, first we need to check for normality. So we will go to Descriptive Statistics, Explore, and we will put cholesterol and blood pressure in the dependent list. Go to Plots, and we need to look at the normality plots with tests. I like to look at histograms because I think they're easier to read than other plots. Click Continue, and OK. So we already know how to check for normality. You can go through the statistics and we can look at the plots. So cholesterol looks pretty normally distributed. We have the stem and leaf plot, we have the QQ plot, which also I think is pretty easy to read. And then let's look at blood pressure, and blood pressure does not look normally distributed. We can go back up to the Kolmogorov-Smirnov test, which we have a big sample, so we're going to choose this one. And it looks like cholesterol is normally distributed. Remember, the null hypothesis is that they are. So in this one, we don't reject the null hypothesis, and we can say that that cholesterol is normally distributed. But blood pressure, we reject the null hypothesis that they are normally distributed, and so we can say that blood pressure is not normally distributed. So when we have at least one distribution that is not normal, we will use the Spearman correlation coefficient. Okay, so to do that, we are going to go to Analyze, and we are going to go to Correlate. This is bivariate, 2 variables. And we are going to choose the 2 variables that we want to compare. Click OK. And in correlation coefficients, click on Spearman because we know that we want the Spearman. Let's just make sure we don't want any options. No. Okay, click OK. Okay, and so we can see here that this is the Pearson correlation. If our 2 variables were both normally distributed, we would look at this table. But because we have decided that one is not, we are going to look at the non-parametric correlations, the Spearman correlation, Spearman's row here. And we can see that the correlation coefficient is negative 0.019. Remember, the closer it is to 0, the less strong is the linear correlation. So we can say that there's not a linear correlation between these two because this is very close to 0. And the p-value is here, significance, two-tail, 0.369. It's not statistically significant. So we would say there is no linear correlation between these two. And we would write the Spearman's row here, which is negative 0.19. The test that we used was the Spearman's correlation. The p-value was 0.369, 0.369. And the conclusion, I would say, is blood pressure and cholesterol are not linearly correlated. We can check that by going to graphs, and it's always important to do a scatter plot when you have 2 quantitative variables. So let's reset. Go to scatter plot, In the x-axis, we will put cholesterol, and we'll put blood pressure in the y-axis. Click OK. And in our scatter plot, we can see that it does not look like they are linearly correlated at all.